Last screencast for Chapter 2, Section 2.10, Negating Statements. And that's exactly what we're going to do. We're going to negate statements that include operators and statements that include quantifiers. So we'll jump into it with examples because we want to use our common sense to negate statements, and then we'll see a couple of principles that establish rules for how we negate statements. So example A, the numbers x and y are both odd. If we want to negate that, if we want to say that this is false, the numbers x and y are both odd is false, then what it means is that x or y is even. Example B, the square of every real number is non-negative. So, the square of every real number is non-negative. If we want to say that this is false, then it means there exists a real number whose square is negative. So, there's something important here that we'll see again later. Every, so this is a for all, a universal quantifier. When we negate a statement with for all, here for all x squared is non-negative, it becomes an existential quantifier. There exists a real number whose square is negative. So when we have a case of a for all statement, to negate it, we exhibit one case where the property doesn't occur. Example C, for every real number x, there is a real number y such that y cubed equals x. Same scenario here, we have for every number x, and if we want to negate this statement, we're going to want to find a number x where that property doesn't happen. So the negation of C is there exists a real number x for which there is no real number y such that y cubed equals x. So we find one case of x where this is not true. Example D, if a is odd, then a squared is odd. So this is an if-then statement, and if we want to say that this is false, then there exists an odd number a such that a squared is even, or there exists an odd number a such that a squared is not odd. So here's a table that summarizes the different case scenarios. First, if we want to negate P and Q, so we want to say P and Q is false, that's basically saying not P and Q. And we've studied that case a lot earlier in the chapter. It's De Morgan's law, so not P and Q is not P or not Q. Negating P or Q is the second of De Morgan's laws, so the negation is not P and not Q. If P then Q, if we want to negate that, what we're saying basically is if P then Q is false. And looking back at the truth tables for if P then Q, the only way that if P then Q is false is when P is true and Q is false. So to negate this, we will do P and not Q. So this refers to example D above. And lastly, with the two quantifiers, what happens for all x in S, P of x, if we want to negate that, we need to exhibit a situation, a case, there exists x such that not px. And if we want to negate an existential quantifier, there exists x in S such that P of x we want to say that this is false, then we need to write for all x in S, not p of x. So we see how the quantifiers flip when we negate statements using them. Thanks for listening.